Alright, so the first quiz question gave us a situation where we vertically shoot up a cannonball from a cannon, and it wants to know at the apex, when the cannonball reaches its maximum height, what is the slope of the tangent line, or what is the instantaneous velocity of it? Okay, so this is actually not a hard problem. There's a couple of ways you can think about it. So I have this little picture here of my cannon being shot up, and here's what happens. Let's follow the trajectory. It just goes up vertically, and then it eventually slows down, and it just kind of comes to a stop at some max, and then it comes down. So just by thinking logically about it, well, initially it's going to have a very high velocity upwards, but then gravity is going to cause it to decelerate, so its velocity is going to shrink as it goes. Then it's going to stop, so it's going to come to a complete stop. So obviously at that point where it comes to a complete stop is at its max, at its peak. So the velocity is going to be 0 there. And then it starts going down. First a little bit, gravity starts causing it to accelerate faster and faster down, and then it's going to come pop right back into the cannon, right back where it started, at a reasonably fast rate. Okay, so that's roughly the way it works, but it's a simple enough question. The velocity at the max is equal to 0. If you graph the height that the cannonball is at as a function of time, and we say initially it has a height of 0, right, so it's immediately coming out of the cannon, it will increase in height, but it's slowing down the rate at which it increases, and then eventually it'll reach a max, and then the height will actually start to decrease, right? It'll start falling back down to the cannon. So the graph should look something like this, and it looks like a parabola. It actually is a parabola if you know about physics. So this actually is a parabola, and you can write down the equation you probably recall from a physics class. So remember that the velocity is also this instantaneous velocity is also given by the slope of the tangent line. Slope of the tangent line at this graph. So what I mean is that at this time, and I don't know what it is, for now I'll just call it time A, when it reaches its max, whatever the slope of this tangent line is, remember that tangent line is just a line that just barely kind of hugs it, whatever the slope of this line is equal to our instantaneous velocity. Our velocity at that instant of time. If you just freeze time for that moment, what velocity are you traveling at? And obviously the slope of this line is 0, and that meshes perfectly with the idea that the velocity should be 0. Alright, so the maximum corresponding to the fact that the slope should be 0 is something that we're going to explore in a major way later on. We're going to make great use of that idea. But the short answer is the velocity is 0 at the top. Now, the next question gave us this interesting function, f of x equals the square root of 1 minus x squared. And they tell us, you only have to consider values of x between -1 and 1. And that's good, because if x was, say, bigger than 1, then x squared would also be bigger than 1. You just square both sides. And then when you take 1 minus x squared, well, you just subtract x squared from both sides, you're going to get a negative number. And you can't take the square root of a negative number. Not in this class, anyway. And something similar would happen if it was less than -1. If it was less than -1, when you square it, less than -1, when you square it, you actually have to swap the sign, because you're multiplying by negative numbers. So the point is, it's not even defined outside of this range, so that's why we're being restricted to this range. Now, I drew the graph, but an interesting question is, well, how do I know that's the graph? You could plug in some easy points. You could say, well, if I did plug in x equal 1 or -1, you'd square that, and even if it's a -1, it would square to 1, right? You'd have -1 squared equals 1. In either case, 1 minus 1 is 0, so you could already have figured out that it passes through 0 at these 2 points. And you could have plugged in x equals 0, and you would have gotten the square root of 1 minus 0 squared, which is just 1, right? Square root of 1 minus 0 squared is just square root of 1 minus 0, which is just square root of 1, which is 1. So you could have also figured out that it passes through this point here. So that's the point 0, comma 1 right there. And that's the point in interest. But how do I know it kind of curves out this way? How do I know it, it doesn't kind of have a sharp peak? How do I know it doesn't do something silly like this? I mean, well, you're going to have to either plot a whole lot of points, which is something I would certainly not want to do and waste time on, or you could just notice that, let me call f of x y. Y is a function of x. So y equals the square root of 1 minus x squared. If you square both sides, that's y squared equals 1 minus x squared. And you can move the x squared over. That's x squared plus y squared equals 1. And hopefully you would recognize that as the equation of a circle. And we can be more specific. Of radius 1, right? It's radius the square root of whatever's on the right-hand side. Radius 1, the square root of 1 is 1. Centered at the origin. The origin. And by the origin, I mean the point 0, comma 0 in the xy plane. Okay? So you can just look at this and say, but we're taking the positive square root. This means we're looking at the positive half. You could have also just plugged it in there, since there's not a minus sign there. So you could have known that this was the equation of an actual circle if you carefully thought about it. And once you've drawn this graph, they ask you, well, what's the equation of a tangent line passing through this point 0, comma 1? So you draw that. And obviously, since it's at the peaks, it's at a maximum, it's clear that the slope of this line is 0. So the slope is 0. You can just tell by looking at it. You can tell by the eyeball. We'll also learn later on that because this is the kind of maximum value, the highest y value that's taken by this graph, that the slope has to be 0 there. We'll learn about that and think carefully about that later on. But there are a couple of ways. You could have just eyeballed it and seen, this is 0, and that's really the only way you could have done it at this stage. Alright, so if you know that the slope is 0, how would you figure out the equation of this line? Well, I mean, this is an easy enough equation. Look, you don't have to make things more complicated than they are. It's passing through the point 0, comma 1, so the y value is 1, but the y value is constant. This doesn't depend on x. It's a constant function. It has slope 0. It's a horizontal line. So you could have just looked at it and said, well, obviously that's the equation y equals 1. Or, if you wanted to go through the mess of it, you could have said, all right, so it passes through the point 0, comma 1, so the equation is y minus the y value over x minus the x value of the point we know, x minus 0, is equal to the slope. And we agreed that the slope was 0. Okay, so you could have multiplied both sides by x minus 0, and you would have gotten y minus 1 equals 0. And then you could have moved the 1 over. So first we did that, then we did this, y equals 1. So you could have gotten to the same equation through more work, and this would be using the point slope formula. That's what I used here. You have the slope is equal to y minus the y value of the point you know over x minus the x value of the point you know. And it leads you to the same place no matter what. Now, how could you have figured out the slope is 0 in maybe a more algorithmic or formulaic way? Well, if you watched the previous video, we would have wrote something like the limit as b approaches a, but a is 0 here, of f of b, but f of b is this horrible thing, 1 minus b squared, minus a, minus my a is 0. I'm sorry, minus f of a, which is 1, all over b minus a, but a is 0. Right? So you would have gotten this horrible limit, the limit as b approaches 0 of the square root of 1 minus b squared minus 1 all over b. I can lose track of that 0 down there. And that's the slope of that line. So it turns out that in fact this is 0, but if you just plugged in the b equals 0, you get a 0 on the bottom. 1 minus 0 squared, square root is 1, minus 1 is 0 on top. You would have gotten a 0 over 0. And 0, 0 can go any which way it wants to. 0 divided by 0, you have no idea what that's going to end up being equal to. You have to do some sort of algebraic manipulation, or use some of the tricks we'll see later on. But this is certainly not a limit I would expect you to be able to do at this point. So you couldn't have really answered this question unless you were just able to draw the graph, draw the picture of what it looks like, and then just realize, oh wait, it reaches its max here, it kind of curves up like this, the line must be horizontal, therefore must have a slope of 0. That's really the only way you could do it. This is a very messy and probably a pretty horrible way of doing it, especially at this stage, trying to compute this limit. So that's how you would do it. So the short answer is the equation is y equals 1, and the answer to the first question is that the velocity was equal to 0.